short tube is a low-inductance winding connected in series with the primary winding of a transformer. The main function of a short tube is to limit the current that flows during a fault on the secondary side of the transformer, protecting the transformer and connected equipment. When a fault occurs on the secondary side, a large current normally would flow through the transformer windings. This high current can cause overheating, insulation breakdown, and potentially catastrophic failure of the transformer. However, the short tube, with its designed impedance, restricts the magnitude of this fault current. The impedance of the short tube limits the current that can flow into the fault. By limiting the fault current, the short tube prevents damage to the transformer itself, such as winding damage from excessive heat or magnetic forces. It also protects other equipment connected to the transformer, such as sensitive electronic devices. Electronic equipment is particularly vulnerable to voltage spikes and other electrical disturbances caused by faults. By limiting the fault current, the short tube minimizes these disturbances and protects the electronic equipment from damage. Short tubes are typically implemented in transformers that supply power to sensitive electronic equipment. This is because electronic devices often are more susceptible to damage from voltage fluctuations and fault currents compared to other types of electrical loads. While not explicitly mentioned in the National Electrical Code, or NEC, short tubes are a common design feature in transformers used in NEC-compliant installations. The NEC focuses primarily on safety requirements for electrical installations such as overcurrent protection and grounding. Short tubes, while not considered a safety device in the same way as fuses or circuit breakers, contribute to the overall reliability and safety of the electrical system by preventing transformer failures and protecting connected equipment. The operation of a short tube relies on the principle of impedance. Impedance is the total opposition to the flow of alternating current in an electrical circuit. It consists of resistance and reactance. Resistance is the opposition to current flow due to the material of the conductor. Reactance is the opposition to current flow due to inductance or capacitance. A short tube is designed to have a specific inductance, which contributes to its overall impedance. When a fault occurs, the sudden increase in current causes a voltage drop across the impedance of the short tube, effectively limiting the current flowing through the transformer. The design of a short tube involves careful consideration of several factors, including the transformer's voltage and current ratings, the expected fault current levels, and the desired level of protection. The inductance of the short tube is chosen to provide the necessary impedance to limit the fault current to a safe level. The physical dimensions of the short tube are also important to ensure that it can handle the expected current and voltage stresses. The location of the short tube within the transformer is also a factor. It is typically placed in series with the primary winding close to the transformer terminals to minimize the impact of the fault current on the rest of the transformer windings. Short tubes are a cost-effective way to protect transformers and connected equipment from damage due to secondary side faults. They are a relatively simple device, but they can provide significant benefits in terms of reliability and safety. While fuses and circuit breakers are essential for overcurrent protection, short tubes offer an additional layer of protection specifically targeted at limiting fault currents. Short tubes can be considered an engineering choice to enhance the protection scheme of the electrical system.